Hi everyone, welcome to week 7. So what are we doing this week? We're actually talking about amplitude envelopes this week. So what is an amplitude envelope? Well, that's the first page. And it's basically something that dictates the amplitude that happens, or you kind of think of the loudness. They're not exactly the same thing, but the amplitude, maybe volume might be an okay way to think about it. But it's the way that the sound increases and decreases in volume over time. So if I look at something like this, I can actually kind of just draw how it's going up and down in amplitude over time, and that would be the amplitude envelope, or at least a representation of the amplitude envelope. Technically, the amplitude envelope of this goes, all the fine grained little nooks and crannies that you see. But in synthesis and in making sounds, I might not want to have something quite so complex as the actual waveform of something, or even as this kind of representation of the waveform. And in fact, we start talking about, here's kind of a sustained sound. We start talking about, just in general terms, what happens to the sound. So you can see a clarinet, where you're blowing into it, it gets to that initial sound pretty quickly in volume, and then it sustains for a while because you keep blowing, you run out of breath, or you stop the note because the note is supposed to be stopped earlier, and it dies away fairly quickly. An acoustic guitar, on the other hand, you have a very fast rise time because the string is plucked. You actually, hit it with a pick or with a finger or with something, and it has a very quick rise to the loudest it gets, and then it dies away over time. You don't have to excite the string. It's just because it's vibrating and you have excited it, it kind of dies away. So those two are different examples, and we start talking about different parts of an amplitude envelope. There's the attack, or how quickly it gets to usually the loudest part of the sound, but not always. It kind of depends, but most of the time, 95% of the time, 95% of the time, it's to the loudest part of the sound, which usually happens at the beginning of the production of a sound. Then we have kind of the steady state, or what happens as we kind of hold the sound. So if I go back to the example of the clarinet, as long as I'm blowing, there is kind of a level at which it's kept. Now that again depends on how much breath I'm putting into the clarinet, and I'm not a clarinet player, but basically that is controllable. But it's this kind of middle state where it's this steady state. And then the final part is the decay, or when I stop inserting energy into the instrument, how fast does it kind of die away back to silence? So if I go back up to these, the bass clarinet dies pretty quickly because it needs that blowing of air to produce a tone. The guitar, on the other hand, although it does die away quickly, it just has to stop vibrating after a period of time. So it's going to take a little bit longer for it to kind of decay away. So interesting. They both, the bass clarinet and the acoustic guitar, both have a very quick attack, you can see. The bass clarinet has a kind of sustained center or steady state. The acoustic guitar has 0 steady state. It immediately, as soon as I excite the string by, striking it, hitting it, plucking it, whatever, it starts to die away and decay. So we have this kind of decay on this. Now I'm using these terms. They're going to get mixed up later because there's been a long history of how we define the terms of this. But if I go down and realize that the attack portion until I get to a steady state actually sometimes is split up. There's the initial rise, and then there's a little bit of a fall sometimes. And that might be able to be heard in a clarinet sound if we're really focused on the beginning part of that sound. So when I blow into a clarinet, I'm exerting a lot of energy right away. But then I sustain. That sustained part might be a little less. So the attack might consist of my initial breath being a kind of a explosion of air through the clarinet, and then that dissipates and I try to keep the breath active. It might be a little less. My cat is actually trying to climb the curtains in the room here in the office. So that's kind of annoying, and I don't know. I think he's ruining my curtains right now. So little diversion. I don't even know what he's out for, but he doesn't have much brains. So sorry about that. Move along. So what I'd like for you to do is, in the next part is a discussion, is go ahead and take a screenshot of a sound waveform. You can do it yourself. If you find a waveform somewhere already, an image of a waveform, you could use that too, I suppose. I'm not going to, care where you got the waveform image from. It's kind of cool to go look at them and kind of chop them and then take screenshots. So that's what I did here. This must be a guitar note too, because I have lots of guitars, sorry. And then as a follow-up, so you just have to post that for your initial post. As a follow-up, I want you to overlay the image. So it basically looks kind of like this second image here, or you could just draw the red part like I did here. So that's the discussion this week. It's kind of a bit of practice of trying to see what the amplitude envelope is. Okay, then we get to how we use an amplitude envelope in synthesis or sound creation. So this is the primary way that we get volume out of our sound source. I mean, sure, we could just directly connect the oscillator to the output, and then you get the tone, like bzzz, and then it's just going to be that. But it's very non-musical, just by itself. So we need to be able to give it shape via its amplitude or volume shape. So the first, one of the early ways to do this was Moog in the modular system was an envelope generator. And so this would output a voltage that would correspond with where you were in the volume. So it's not outputting a voltage that makes the sound source like an oscillator did. This one actually modifies the sound source with this voltage, so it kind of creates the volume over time. And so we had a few controls and then a sustain level for, those are the 4 controls. And that turned into this ADSR. ADSR, now this is where things get weird because we had attack before, same thing. We had decay, but now it's really that second part of the attack where it goes up to the peak and then it comes down to the steady state. So the decay in an ADSR envelope is not the decay I just talked about before where it decays at the end of the note. That's actually now called the release. So back in order, we go attack, which is how quickly the sound gets to its maximum volume. We get the decay, which is how quickly it gets to the sustained level. Remember, bass clarinet, I'm blowing into it. The sustain is now a level, not a time, because it's forever how long I excite the sound. And by exciting the sound in synthesis land, it means how long I'm holding the key down. So when I press a key, I get a quick, it doesn't have to be quick, sorry. I get an amount that's an attack, an amount of time for it to decay back to the level. If I keep holding the key down, it's going to be at the sustained level for as long as I hold the key down. Then I can release my finger, which is maybe where we get the term release from, and that is how long it takes for the sound to completely die away. So again, attack is a length of time for it to get up to the max. Decay is a length of time it takes to get down to a sustained level. Sustain is a level at which it stays for as long as I hold the key down on my controller, or for as long as I send it a kind of an on control voltage or something like that. And then release would be the amount of time it takes for it to completely die away as a sound. So that's what I have here. A little Dr. Mix video that kind of explains that. The reason why I like this video is it's got a lot of good examples in it. So please watch that, and you'll see how, you can change those things. And you want to start thinking about, hey, in the sound, that I have in my head, how do I use, how quick is the attack? How quick is the decay? How long does it have sustain? If it does, how much sustain? Does it go up the attack and stay almost at the top? Or does it kind of go down quite a bit and then stay really low? Or maybe there's no sustain, think percussion, kick drum, unless you're, a synthetic 808 kick or something like that. A kick drum does not have natural sustain. It dies away. The guitar note that we saw before doesn't have natural sustain. It decays away. And then you have a release, which is after you let up on the key. So how much time it takes to do that. Okay, so as you can kind of imagine, and you probably tried to draw at the beginning of the session, this week's module, you might not have straight lines to go from each segment. And so very often you'll have kind of these curves, and sometimes I could even modify those in synthesis programs or virtual instruments. So I have a couple of examples. So this is from Falcon. Sometimes there's just an attack decay. So, and I can kind of see that looks a little bit like that guitar note. So if I don't need an ADSR envelope, I just need the attack and the decay, boom, I have it here. And I can use that, things like that. They get more complicated than an ADSR too, an AHDSR, where I kind of have a hold for usually a period of time. So it's the attack goes up to the peak, but then I hold it at the peak for a little bit, and then I have the amount of time that it decays to that sustain level. So this is, I think, taken from Alchemy. Yes, I took that from Alchemy. I have AHD, which is, you can probably guess, you have an attack, you have a hold, and you have a decay, so you don't have sustain or release. These are, again, for items that are non-sustaining. Again, this is from Falcon. Falcon here again, we have a DAHDSR. So what this is, and it goes down to this complex envelope from Native Instruments FM8, looks like this, along with some of their other virtual instruments. But basically, you're getting the idea that if I have more points along to define, I can make a more and more complex envelope. So the D in the DAHDSR in both places mean a delay of how long it takes before it even starts the attack, and then how long it takes to go down to the sustain level. So so we have the D is actually a straight delay of how long the envelope takes to work. We have the attack, we have the hold time, we have the decay time, which is that second D. We have a sustain level where it's just going to stay for as long as I keep the key pressed or send it, a note on before I send the note off event, and then a release of how long it takes to die away. So, and then even more is you might have dynamic envelopes where those parameters that you're changing aren't static. They depend on maybe velocity or maybe where you're playing them on the keyboard. For example, a piano, if you just press and push down a really low note, it has a bigger length of time. It sustains more, or decays more, I should say, than one of the highest notes on the piano. So you might want to change this envelope depending on other parameters. So we get to, that's kind of it for envelopes, at least amplitude envelopes. We'll talk about other types of envelopes later. So we get to the quiz. Again, you have 2 times to do it, 30 minutes to do that each time. So try it, figure it out, see the answers, do the test again, and you should be all good. 2 more things I want everyone to do this week, and I put them after the quiz because we'll talk about them more in class as well, is really you need to get your synthesizer demo chosen, because the next few weeks, we're basically, this is the halfway point at the end of this week 7. From here on out, we'll have assignments about that synthesizer that you are going to demo. And so you really want to get set up with those. I will be happy to talk to you about any particular choice you might want to pick. And there's lots of free software synthesizers. I have a page here that pulls up a big list of paid and free ones, and you can go check all of these out. There's a ton of free ones in here. There's some paid ones. All is fine to do. Some things are going to be harder than others to do. For example, C Sound is a programming language, and that you'd have to do everything kind of from scratch. VCV is another one that people like to do it, which is really cool, but they better dive a little bit deeper because it's a kind of a modular Euro rack emulation. And so it might be a little harder to do some of that. Other ones on here, like Reason Studio's Reason, is a great program, but it has lots of different synthesizers in it, kind of like Logic does or Live does. And so, you'd want to just clear which particular synthesizer you're doing, because there's some that'll work, there's some that won't work. There's iOS ones in here, and I apologize, I don't know much about Android options, but I'm happy to look if you have an Android synthesizer. I'm happy to look at it really quick and give you a thumbs up or tell you maybe how it's not going to work with our assignment. So that is if I go back, synthesizer demo choice, and you just got to insert your choice here. You don't have to reply to anyone else or anything like that. This is just stick up what you have so we have a record of what you've chosen. Same thing for the emulation project. So all I need, and I've been talking about this for the whole class, I need the song that you're using, and then I need the 2 sounds. Just identify them by, basic, sound type and the location at where that sound exists. So I said I want the bass sound that starts almost at the beginning of the song, and then the whip sound that sounds at 11 seconds. And something tells me that's not quite the time. So, but hopefully you get the idea. Is you're going to emulate 2 sounds from this song that you're choosing. So you got to be able to listen to the song, 100 times or at least a snippet of it 100 times in a row, because you're going to be comparing and trying to get to that sound that you're matching. So that's it for this week. I hope you're having a great week. Hope you're having fun in the class still. Let me know if you have any questions or concerns. Have a great day, and I'll see you in class. Bye.